All right, matter in a nutshell. So we're going to talk about the three different states of matter. Technically, there's four with plasma. We're not going to discuss plasma. So let's get started. So classification of matter. Anything that has mass and takes up space is considered matter. So anything that has mass and volume, basically. Occupying space is basically a definition of volume. The amount of space something takes up is how much volume it has. So in the picture, you'll see three different examples. You have a solid, which you can tell from the picture is not really able to take the shape of its container, has a pretty much constant shape, and looks like it has a constant volume as well. You have a liquid, which does take the shape of the container based on the amount of liquid you have, and looks like it has more or less a constant volume. And you have a gas, which takes the shape of its container and has the volume of its container as well. So let's talk about solids first. So in terms of the atomic level, you'll see that the particles are very closely stacked together. That's the characteristics of a solid. That's why they have very little motion. And most of you guys may look at it and say, well, there's no motion at all. It does. It's like vibrations in place, nothing noticeable, but it does have slight motion. For the most part, you can't really change the shape of it unless you break it, and the volume is pretty much constant. So constant volume and shape are the two characteristics of a solid. That's what we use to identify it. Two types are amorphous and crystalline, and the difference between these two is based on how the particles are organized. Let's talk about crystalline first. Crystalline has a really nice organized pattern. You can see it's a repeating pattern. There's a rhyme and reason to it. Things like diamond will be considered a crystalline solid. Salt, sugar, also two examples of crystalline solids. Now, obviously, diamond's very strong because the way that the atoms are bonded together, where salt and sugar, as you know from experience, are not very strong. You could break it with a hammer pretty easily, but you can't for diamond. So it's not just that they're a specific type of solid, there's also characteristics as far as the way that the atoms are connecting to each other that dictates their characteristics. All you need to understand about crystalline solids is a very organized pattern. Amorphous solid, on the other hand, see the difference? There is no organization. It's all randomized. Take a look at crystalline again. See how it's a nice geometric pattern repeating. Amorphous, no pattern whatsoever. These four are together. These three are together. This one's by itself. There's no pattern like you would see in a crystalline solid. So we call it having a random distribution of atoms. Things like charcoal we consider amorphous. So you can tell right off the bat it's not as strong possibly as your crystalline solids, and that's really the case. Plastic, glass, those are also examples of amorphous solids. So it's important to not only note the explanation of what it is, but also some examples so you could visualize it in your head. So let's try some questions. Place an S if the following is a solid, and O if it's something other than a solid. Now for dough, if you've ever played with dough, like Play-Doh, for example, even, which is the same principle as how they make it, with flour and water, you understand that it doesn't really take a characteristic of a solid which has a constant volume and shape. You can change the shape of dough pretty easily. So I'm going to put this in the other category because it doesn't look like one thing or another. Sponge, if it's wet, it changes shape. If it's not wet, then it's pretty constant in shape. So you could borderline say this is either a solid or other, depending on how you're using it. Sand will be considered a solid, obviously, because it just has silicon dioxide, which is those sand particles that you see at the beach. Sugar, it's a solid. You want to be exact, crystalline solid. Coins, also a solid. Glass, solid. And if you want to be exact, amorphous solid. Whipped cream, another category, right? It doesn't really maintain its shape, but it doesn't act like a liquid either. Definitely not a gas because you can see it. So we're going to stay in the other category. And same with hair gel, other category. Because even though it is somewhat like a solid, it doesn't completely meet all the characteristics of it. All right, let's talk about liquids. So liquids, you see how there's a little bit more space between the particles. So besides being able to move more than solids, so solids have no motion, almost no motion. Liquids have a little bit more motion. That's what allows them to slide past each other and create this kind of dynamic you're seeing here where the liquid is taking the shape of its container. So our characteristic of a liquid is it has a constant volume, but shape can change. And that's how we're going to define it. Gases, volume and shape can change. Look how much distance between the particles. This is the fastest moving of the three states of matter. It also has the most distance between the particles. And because of that, it can take the shape of whatever you put it in, and its volume is whatever you put in. So if I put in a 2-liter can, that's its volume, 2 liters. If I put in a 1-liter can, that's its volume, 1 liter. So the volume is basically based on wherever you put that put that gas. And those that are hard to define, substances that like gel, whipped cream, you really can't identify as a solid, liquid, or a gas, so we just say it's in the other category. And that's the 3 different states of matter.